This is what you're seeing here. A nuclear fusion reactor in action. Look at that glowing plasma. That's not computer graphics, it's real. Energy being created by smashing atoms together, the same process that powers the stars. It's mesmerizing, isn't it? You're watching one of humanity's most ambitious experiments, a Tokamak reactor. And today, my friends, I'll explain exactly what's happening in that incredible machine, why it matters, and how it connects to something much bigger. The search for intelligent life beyond Earth and one of the strangest cosmic objects ever discovered, 3I/ATLAS. Because in this video we're going to explore three stories that all in their own way touch the same question. How far can technology and curiosity really take us? So here's the plan. First, we'll dive into a recent article from Universe Today discussing why we haven't found alien civilizations yet and why we might only have a tiny window of time, a cosmic blink, to detect them before they vanish from our reach. Then we'll move to this amazing footage of the Tokamak ST40 fusion reactor, a project that could redefine the future of energy on Earth. And finally, we'll analyze the latest image of the interstellar object 3I/ATLAS, an object so strange that even Harvard astrophysicist Avi Loeb calls it a scientific mystery. So buckle up. Today we're going from the heart of an artificial star to the farthest corners of the cosmos. And if you enjoy this kind of deep exploration of science, space, and technology, don't forget, leave a like, subscribe, and share your thoughts in the comments. That's how YouTube knows you want more of this kind of content, and it really helps this small channel grow. Thank you, truly. All right, let's start with that Universe Today article, because it might just explain one of the greatest paradoxes in science. If the universe is full of stars, full of planets, full of opportunities for life, where is everybody? The article opens with a question that has haunted scientists since the days of Enrico Fermi. Why haven't we detected any alien civilizations? The answer, it suggests, might have to do with the speed of technological evolution. You see, Carl Sagan proposed something in the 1970s called the communication horizon. It's a fascinating concept. It describes the brief period during which a civilization's communication methods are still detectable to others like us. Imagine this. When a civilization begins broadcasting radio waves, television signals, radar pulses, it becomes visible across the galaxy. But as it evolves, its communication becomes more advanced, compressed, encrypted, transmitted through quantum channels or neutrinos. In short, it becomes invisible to less advanced observers. Sagan estimated that this detectable period might last around 1,000 years. But now, with AI and exponential technology, that window might have shrunk to just a few decades. Think about that. If alien civilizations progress as quickly as we have, from primitive transmitters to AI-managed networks in less than a century, then the odds of two civilizations existing at the same level of detectable technology, at the same time, within the same cosmic neighborhood, are unimaginably small. That's the cosmic blink. The brief fleeting overlap in which one civilization could even notice another. After that, both may vanish from each other's view, not because they're gone, but because they've evolved beyond each other's understanding. Now, the article connects this with AI, and that's where it gets interesting. It argues that artificial intelligence accelerates this transition. Once AI takes over communication, manufacturing, and even exploration, civilizations may leap so fast technologically that their detectable phase becomes almost instantaneous on a cosmic timescale. Carl Sagan's 1,000 years could collapse into 50, or 10, or maybe just 1. And you know what? You can actually see that acceleration in our world today. Remember those early AI videos from 2 years ago? The bizarre, uncanny ones, like that viral clip of Will Smith eating spaghetti? Compare those to today's photorealistic AI footage of animals saving babies or tornadoes caught in stunning slow motion. It's getting impossible to tell what's real and what's generated. That's exponential growth. And if our technology is accelerating like that, imagine a civilization 10,000 years ahead. They wouldn't need radio or optical signals. They could communicate using particles we haven't even detected yet. Neutrinos, gravitational waves, or even quantum entanglement across vast distances. So maybe the universe isn't silent. Maybe it's whispering, but in a language we don't yet understand. The article closes with a powerful statement. Humanity's chance to detect other civilizations may only last for a cosmic blink of an eye. After that, we'll move beyond the detection range of others, or they'll move beyond ours. Either way, the silence we perceive might just be the sound of progress. And that's a sobering but also inspiring idea, because it means we're living right now in one of the few moments when interstellar communication is even possible. We're inside the blink. All right, now that we've explored the vastness of cosmic communication, let's bring things back down, literally, to Earth. Because while we search for alien technology out there, we're building our own here. Let's talk about nuclear fusion, the power of the stars. The footage you saw at the start of this video was taken from Tokamak Energy's ST40 reactor. This is a private UK-based project aiming to achieve what scientists have been chasing for over 70 years, controlled nuclear fusion. So what's fusion? In simple terms, it's when two light atomic nuclei combine into one heavier nucleus, releasing enormous energy in the process. That's what happens inside the sun every second. Hydrogen atoms fuse into helium, releasing light and heat. It's clean, it's powerful, and it's virtually limitless. But recreating that on Earth, that's a nightmare. Fusion requires temperatures of over 100 million degrees Celsius, hotter than the core of the sun. Nothing on Earth can contain that heat. So scientists use magnetic fields instead of solid walls. That's where the tokamak comes in. The word tokamak comes from Russian and means toroidal magnetic chamber. It's a donut-shaped device designed to trap and stabilize plasma. That's the superheated gas where fusion happens, using powerful magnetic fields. In this ST40 footage, what you're seeing is a plasma pulse filmed at 16,000 frames per second. Each pulse lasts only 0.2 seconds, but during that instant, you're witnessing matter in its most extreme state. The pink light you see, that's the edge of the plasma glowing. Now, one of the upgrades in this experiment involves injecting lithium into the plasma. Lithium acts like a kind of buffer. It glows red when excited and turns green when ionized, revealing the magnetic field lines that hold everything in place. But here's the part that amazes me. People often ask, how does this thing not destroy the building it's in? I mean, isn't that hotter than the surface of the sun? Yes, it is. But it doesn't destroy the building because it never actually touches it. The plasma is suspended inside a magnetic bottle, confined and stabilized by invisible forces. It's like levitating lightning. And that's not an exaggeration. The magnetic fields are so strong they can lift cars or crush them, depending on the setup. The ST40 project, funded with about $52 million in partnership with US and UK energy departments, is part of a new generation of compact fusion reactors. The scientists are studying something called X-point radiator regimes, which help cool the plasma before it strikes the reactor walls. This reduces wear and increases efficiency. Crucial steps toward making fusion viable. Because right now, the main challenge with fusion is simple. It takes more energy to run the reactor than the energy it produces. That's the big barrier. It's like spending $10 in electricity to make $1 worth of fusion power. But every year, that gap is shrinking. In December 2022, for instance, the U.S. National Ignition Facility achieved net gain for a fraction of a second. More energy out than in. It was a symbolic victory, but still historic. So when you look at these glowing rings of plasma, you're looking at humanity inching closer to mastering the same force that lights up the stars. Imagine what that means. An energy source that produces no carbon emissions, no long-term waste, and practically infinite fuel. Fusion could power entire civilizations sustainably for millennia. And you know what's poetic about it? The same process that might power alien civilizations, the same energy that burns inside every star in the universe, could soon power our homes. The more we explore space, the more it feels like the universe is holding up a mirror, showing us what's possible if we evolve fast enough. But speaking of fast evolution, let's talk about something that's been evolving in a very strange way. The interstellar object known as 3I/ATLAS. You've probably heard the name before. It's only the third confirmed interstellar object ever detected, after Oumuamua in 2017 and Borisov in 2019. But this one is special. On August 2nd, 2025, the twin 2-meter telescope in the Canary Islands captured a new image of 3I/ATLAS showing something bizarre, a faint jet pointing toward the sun. That's right, toward the sun. Normally, comets have tails that point away from the sun, pushed by solar radiation and wind. But 3I/ATLAS seems to have an anti-tail, a jet of dust and gas extending in the opposite direction of what physics predicts. You can see it clearly in the image. The sun is here, off to one side, and this faint streak of light goes toward it. That's not how comets behave. This anomaly isn't new, by the way. The Hubble Space Telescope had noticed a similar feature earlier this year, but seeing it confirmed again from ground-based observations made scientists double-take. Avi Loeb, the astrophysicist from Harvard you probably know from the Oumuamua controversy, wrote a detailed post about it on Medium. He and physicist Eric Q tried to model the phenomenon, but they admit it's not easy to explain. The kind of particles that could scatter light this way should actually be repelled from the sun, not attracted. Loeb's point is simple. Calling 3I/ATLAS a comet and moving on ignores too many anomalies. He lists them one by one. An anti-tail facing the sun, an unusually high mass and velocity for an interstellar object, a trajectory almost perfectly aligned with the ecliptic plane, the same plane as the planets, which is statistically rare. Close flybys near Mars, Venus, and Jupiter, almost like a sequence of gravitational probes, and a composition rich in nickel gas but with very little iron, which, according to Loeb, is highly uncommon. That last point has sparked debate. Some recent studies by ESO scientists do report traces of iron, but in much smaller amounts compared to nickel. Still, that unusual ratio might indicate a unique origin or process, something not typical of known comets. Loeb also mentions its extremely low water content, just about 4%. For a supposed comet, that's surprisingly dry. Add to that an unusually strong negative polarization, meaning the light it reflects is polarized in the opposite way from normal comets. And you start to realize why so many astronomers are puzzled. And then there's the kicker. Its origin appears to trace back roughly toward the direction of the 1977 WOW signal, that famous unexplained radio burst detected in Ohio. Now, Loeb himself doesn't claim 3I/ATLAS is connected to the WOW signal, but he points out the coincidence and argues that dismissing it outright would be unscientific. He closes his piece by suggesting that the scientific community should remain open-minded and perhaps use advanced AI systems to reanalyze data from interstellar anomalies, because, as he puts it, human bias can sometimes blind us to the extraordinary. And that's true. We've seen it before with Oumuamua, how quick the world was to label it just a rock, even though its acceleration and shape didn't match any known natural object. So maybe 3I/ATLAS is another chance to learn or unlearn what we think we know about the universe. It's expected to reappear from behind the sun in December after a superior conjunction that makes it unobservable right now. And when it does, all major telescopes, Hubble, JWST, Hayabusa 2, and more, will be watching. Because whatever it is, 3I/ATLAS is testing the boundaries of our understanding of cosmic behavior. And in a strange way, it ties back to everything we've talked about today, from the communication horizon to fusion. All these stories are about the same thing, thresholds. The thin, fragile line between what we can detect and what lies just beyond. Between energy we can control and energy that controls us. Between the known and the unknowable. And that's where I'll pause for now, because the next part of this journey goes even deeper into what these discoveries might mean for the future of science, technology, and our place in the cosmos. So let's continue from where we left off, standing at the edge of mystery. The anti-tail of 3I/ATLAS pointing toward the sun, a nuclear reactor imitating the power of a star, and Carl Sagan's haunting prediction that we may only glimpse alien civilizations in a fleeting cosmic blink. All these threads tie together in a pattern, one that suggests the universe might be far more interconnected, far more alive than we dare to admit. When we think about 3I/ATLAS, we're really thinking about our limits. Limits of understanding, limits of technology, limits of imagination. And that's what makes this object so fascinating, because every time we try to box it into one category, comet, asteroid, debris, it refuses to fit neatly. Its anti-tail, its composition, its trajectory, its behavior, everything about it seems to whisper, "Look closer." Avi Loeb wrote that 3I/ATLAS might force us to rethink how we classify interstellar visitors altogether. Maybe it's not a comet. Maybe it's something in between, a transitional type of body, or even something artificial. Not necessarily alien technology, but a byproduct of physics we haven't yet uncovered. That's how science progresses. When something breaks the rules, we write better ones. Think of how we once thought all planets revolved around the Earth. Then one day, a few small dots in Galileo's telescope shattered that illusion. 3I/ATLAS might be our next Galileo moment, a cosmic mirror forcing us to confront the vastness of what we still don't know. And that humility, that willingness to question, connects directly to the second theme of today's journey: technology as a measure of civilization. When Carl Sagan spoke about the communication horizon, he was really talking about evolution, not biological, but technological evolution. He understood that intelligence doesn't stand still. It adapts, accelerates, transforms. And what's happening with AI today is exactly what Sagan foresaw, but on steroids. Think about it. Just a few years ago, AI could barely generate a coherent sentence or a recognizable face. Now it can simulate entire worlds, produce fake yet photorealistic videos, and write code that runs satellites. In a decade, it might design its own experiments, analyze astronomical data, and even interpret signals from deep space faster than any human could. So, when Sagan said advanced civilizations might become undetectable, it wasn't just speculation, it was prediction. Because look at us, we're already halfway there. We're replacing human-readable signals with machine-to-machine communication. Our systems are becoming opaque to us, hidden behind layers of algorithmic compression and encryption. If an alien scientist were listening in, they might hear nothing. That silence wouldn't mean we vanished. It would mean we evolved. And that brings us to a profound realization. Maybe the universe isn't quiet at all. Maybe it's saturated with communication, but it's communication that we, as an early-stage civilization, can't yet perceive. Like a child trying to hear radio waves without a receiver. That idea changes everything. It means that the great silence might not be a void. It might be a symphony we're not yet tuned to hear. Now, let's circle back to nuclear fusion, because it ties directly into this theme of evolution. Fusion is humanity's attempt to replicate the natural process that powers the stars, to master the very energy that sustains life across the cosmos. It's our own step toward becoming a Type 1 civilization on the Kardashev scale, one that can harness all the energy available on its home planet. When you think about it that way, the Tokamak reactor isn't just a scientific experiment, it's a declaration. It says, we, a fragile species on a small blue planet, are learning to create starlight. Fusion represents more than energy. It represents continuity. Every civilization that survives long enough must eventually learn to generate sustainable power. Otherwise, it burns out, Maybe that's what separates the civilizations that vanish after their blink from those that transcend it. And yet, as we push forward, we're also creating new paradoxes. The same AI that could help us achieve fusion could also outpace our ability to control it. The same telescopes that peer into the cosmos could generate data too vast for any human to interpret. So, we rely more and more on machines. And in doing so, we begin to resemble the very civilizations we're searching for: advanced, efficient, and increasingly invisible. That's the irony, isn't it? In trying to find others, we might be evolving into the kind of beings they already became, undetectable to the next generation of curious life forms. But back to 3I/ATLAS, because this object is becoming a kind of symbol for all of this. It's out there, drifting between stars, possibly carrying secrets from another solar system. And we're here on our tiny planet, trying to make sense of its clues through faint light and scattered pixels. Every time a new image appears, astronomers scramble to interpret it. The anti-tail, the unusual composition, the alignment with the ecliptic, these details are like breadcrumbs leading us towards something profound. Maybe not aliens, maybe not machines, but something different. Something that expands our sense of what's possible. And that's what makes Avi Loeb's work so important, even when it's controversial. He dares to ask the forbidden question, what if it's not natural? And that's not a declaration. It's an invitation to imagine. Because science without imagination is just data. It's imagination that turns numbers into meaning. Loeb's critics often accuse him of sensationalism. But let's be honest, most breakthroughs start as sensational ideas. Quantum mechanics sounded like nonsense once. The idea of black holes was laughed at for decades. Even plate tectonics was dismissed as fantasy. And now they're foundational. So maybe 3I/ATLAS will one day take its place among those once ridiculed mysteries that changed everything. Imagine for a moment that 3I/ATLAS isn't just a comet. Imagine it's a fragment of an ancient interstellar craft, something built eons ago by a civilization that reached its communication horizon and moved beyond detectability. What if what we're seeing isn't a tail of dust, but the residue of technology so advanced it looks natural to us? That's speculation, sure, but speculation is the spark of discovery. As we approach December, when 3I/ATLAS is expected to re-emerge from behind the sun, the world's telescopes are ready. JWST will analyze its spectra again. Hayabusa 2's instruments might capture new data from its optical sensors. And amateur astronomers around the globe are preparing for one of the most anticipated skywatching events in recent memory. Why? Because this is the kind of mystery that unites people. It's not political, it's not national, it's cosmic. For a brief moment, humanity looks up together. And that's the beauty of science communications, of sharing knowledge across borders. When someone explains these phenomena in a way anyone can understand, it's not just education, it's empowerment. It reminds us that curiosity is universal. That's why I always say, leave a comment, share your thoughts. It's not just engagement metrics, it's conversation. It's the continuation of a tradition that started when humans first looked at the stars and asked, what's out there? Speaking of conversation, I want to bring something new to this channel. A small gesture, but one that means a lot to me. I want to highlight the people who make this work possible. You, the viewers who take time to comment, to discuss, to question, to encourage. So, like I did in the last video, I want to read one of your messages again. This one comes from Richard Hector. He wrote, "Great content, it's explanatory. Criticism is part of it because I always see people complaining instead of appreciating the effort to simplify complex science. It's not easy to explain these things clearly. Congratulations on making it understandable for everyone, Richard. Thank you. That means a lot. Because honestly, that's what keeps creators like me going. The internet can be harsh. There's always someone ready to dismiss your work or twist your words. But when someone recognizes the intent, the effort to share science honestly and clearly, That makes all the difference. And this is the part of the video where I want to speak directly to you, watching this right now. If you've been here for a while, you know this channel isn't about sensational headlines or fake mysteries. It's about genuine curiosity, about asking questions, exploring data, and sometimes daring to imagine. Because science isn't about certainty, it's about exploration. Every discovery starts with what if. So what if Carl Sagan was right, and we're living through the only detectable phase of our species' history? What if our descendants evolve beyond the need for physical communication, using technologies that operate outside light and matter? What if right now other civilizations are watching us the way we watch comets, faintly, distantly, knowing we'll soon pass beyond their reach? What if the universe is full of life, but life that has already crossed its communication horizon, leaving only relics like 3I/ATLAS drifting in the dark? Those are the questions that keep me up at night, not out of fear, but awe. And that awe, that feeling of standing at the edge of understanding, is what drives every scientist, every astronomer, every dreamer who's ever looked up and thought, we can do more. Fusion reactors, interstellar mysteries, artificial intelligence, they all point in the same direction, the future. And maybe, just maybe, they're all connected parts of a single narrative, the story of a species waking up to its place in the cosmos. When I watch plasma swirl inside a tokamak, I don't just see energy, I see evolution in motion. When I read about Sagan's communication horizon, I don't just think of aliens, I think of us one day, becoming the ones who disappear beyond that line. And when I look at 3I/ATLAS, that faint traveler from another star, I don't just see a comet, I see a message, a reminder that the universe is alive with stories if we know how to listen. And maybe that's what makes this era so special. We're the first generation capable of capturing these signals, from particles in a plasma reactor to photons from an interstellar visitor, and understanding their meaning. We're witnesses to a moment when human curiosity and technology converge like never before. But we're also fragile. We stand on a knife's edge between enlightenment and chaos. The same tools that can save us can also destroy us. That's why communication, honest, open, transparent communication matters more than ever. It's why channels like this exist, not to claim absolute truths, but to keep the dialogue alive, to make sure that as we advance, we don't lose sight of wonder. So as we wait for 3I/ATLAS to return, as scientists tune their instruments and AI crunches terabytes of data, I want you to remember something. Discovery doesn't just happen in labs or observatories. It happens here, in conversation, in curiosity. In the moments when you ask yourself, what if this changes everything? Because maybe it will. Maybe when we finally understand what 3I/ATLAS really is, it won't just be another entry in an astronomy catalog. Maybe it'll be a mirror, showing us how far we've come and how far we still have to go. Maybe it'll remind us that the same fire we're trying to control inside tokamaks burns in our own curiosity, that the light we're chasing across the stars is the same light we're trying to recreate here on Earth. That's the poetry of science. It's not just knowledge, it's connection. So, before we end today's video, let me leave you with a thought. The next time you see a photo of a fusion reactor glowing pink and blue, or an image of a faint comet streaking across the darkness, remember, those are the same processes, the same physics, the same universe, viewed from different angles. We're part of that. We're made of it. And every experiment, every discovery, every late-night conversation like this one is another spark in the endless fusion reaction of curiosity. Thank you for being part of this journey, for supporting, for questioning, for caring. Don't forget to like, to share, to subscribe if you haven't yet. Not just to help the channel, but to keep the conversation alive. Because the more we talk about these mysteries, the closer we get to understanding them. And maybe one day, when another civilization looks at our faint signal drifting through space, they'll say, they were here, they wondered, they tried. Until then, keep looking up, my friends. The answers are out there, waiting for us to ask the right questions. See you in the next video.